In this video, we'll look at 8D, which is again looking at arithmetic sequences, but this time using a recurrence relation to generate and analyze the sequence. So if we first of all look at the arithmetic sequence here, we've got 2, 6, 10, and 14. And hopefully we can all see that the sequence follows the rule of adding 4 to the next term. So plus 4 to 2 gives me 6, plus 4 again, I get 10, plus 4 again, I get 14. Now, a recurrence relation is a way for us to express this rule in mathematical language. And what a recurrence relation does is it states T1, so the first term, first of all. So we say T1 equals 10, comma, and then we say Tn plus 1 equals Tn plus 5. And what this notation over here, Tn plus 1, means the next term, and Tn means then the previous term. So the next term comes from taking the previous term and adding 5 on. So if we look down here again, we have this standard form here. And using those letters that we were used to last time, we said that the rule for the nth term was Tn equals A, where A was the first term, plus n minus 1 times D. D was the common difference. This time we're actually explicitly stating that T1 equals A. And then we're saying, like I said, the next term, Tn plus 1, comes from the previous term plus, or it could be minus, that common difference. So that was that amount, again, that we are adding or subtracting over and over and over again. So what we're going to do is we're going to scroll down and look at an example here. Question 1, it says generate and graph the first 5 terms of the sequence defined by the recurrence relation, and then we've got T1 equals 35 and Tn plus 1 equals Tn minus 7. Now that means that we've got a first term of 35 here, and that common difference is minus 7, so we need to keep minusing 7 each time. So in this case, T2 comes from taking 35 minus 7, which we know is 28, 21. Hopefully you can work with your 7 times tables here to get those first 5 terms. Just a reminder, you could have done that in your calculator as well by putting in your first term of 35 like we did last time, and then saying minus 7 and pressing enter. That'll give you second term. And remember, if you keep pressing enter, I'll just move the keyboard so we can see it all on the same thing. If we keep pressing enter, we've now got the first, second, third, fourth, fifth term there, so we can see them all. Now, this question, it wanted us to graph the first 5 terms as well. So if we set up some axes here for us, let's call this 40, 20, so 30 and 10, and we've got 1, 2, 3, 4, 5. So this axis is n and this up here is Tn. Our first term is 35, so that's going to be up here. Our second term is 28, so in here, 21, 14, and finally 7. And so we can see again that we get a straight line forming here, and if we were to talk about this, we could say that we've got a downward slope, and hopefully we remember our word that we use here then is decay, because our numbers are decreasing over time. Now, part B, it says use a rule to calculate the value of the 19th term in the sequence. Technically, we could keep using the rule that's on the screen at the moment, and if I go to my calculator, I could keep counting and pressing enter, so I could go my 6th, 7th, 8th, 9th, 10th, 11th, 12th, 14, 15, 16, 17, 18, 19. As you can see though, that is quite laborious to keep doing that over and over and over again to get to 91. So this is when it's handy to use our nth term rule, that Tn rule. So I could actually rewrite this rule that we had in terms of just Tn, and that, remember, that becomes 35 plus n minus 1 times that D value, in this case negative 7. So if I did this for T19, I get 35 plus 19 minus 1 times negative 7. And I can pop that as is written into my calculator here. So if I go 35 plus bracket 19 minus 1, negative 7, I still get the same answer of negative 91. So as you can see, it is really handy for us to have this rule for the nth term or for any term to be able to use that rule. If I scroll on down, I have another example for us to do. This one's from our textbook. It does have some snake shapes. It said the shapes below are made using blocks, each with a side length of 1 unit. So we can see with the first shape, each, say, row or column only has 2 blocks in a line, and then when we get the second snake, we've added in blocks, so we've got 3s, and then again we've got 4s, etc. Now, each block has a side length of 1 unit, and it says that the perimeter of each snake can be found by counting the sides of the blocks around the outside of the shape, and the perimeter of each new snake is 6 units longer than the previous snake. If we count this, we can see that for our first snake, we've got a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. It says here that it's adding 6, so this one should be 16, but we can double check. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16 units. And lastly, over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 units. So a recurrence relation modeling this situation, we've already got a rule written for us. It says that P1 equals 10, so the perimeter for my first snake is 10 units, which agreed, we've just checked that. And the next term comes from taking the previous one and adding on 6. So we're adding 6 each time to the perimeter when we're adding an extra block horizontally and vertically. So the question here, then we've got a few steps to go through. Part A, it says, what does P1 tell us? Well, P1 is the perimeter of the first snake, which is 10 units. This question also says, what does the rule in the recurrence relation tell us? And the recurrence relation rule tells us that the perimeter of the next snake is 6 units bigger than the perimeter of the previous snake. You could also write that as adding 6 to the perimeter of the previous snakes gives you the perimeter of the next snake. It's your choice how you write that. It says use the recurrence relation to generate the perimeters of the first 4 snakes in this sequence and construct a table showing the snake number and its perimeter. So we know that our first snake equals 10. If I'm using the rule, I do need to show that I'm using the rule. So what we're saying here now is P of 1 plus 1, which in this case is P2, comes from taking P1 plus 6. So I can rewrite this here as P2 equals 10 plus 6, which is 16. So they are my first 2 terms. If I do my next one, 2 plus 1 equals P2 plus 6. So the perimeter of the third snake is 16 plus 6, which is 22. We already counted that and worked that out. And if I do the last one, 3 plus 1 is P3 plus 6, or the perimeter of the fourth snake is 22 plus 6, and that will then give us a snake with a perimeter of 28 units there. So my first 4 terms in this case are 10, 16, 22, and 28. Now the question here wants us to make a table, showing this. So if we put this in a table, N is the snake and Pn is the perimeter. So 1, 2, 3, 4. 10, 16, 22, 28. Those are those first 4 snakes. Part It's all part B. Part C wants us to plot this as a graph and then comment on the shape of it. So if we graphed this, I'm just going to give us some space over here. This is N and this is Pn, that perimeter. I can put here 1, 2, 3, 4. And then we are going up to 28, so let's call this 30, 20, 10, and the bits halfway in between. Our first snake has a perimeter of 10. Our second snake has a perimeter of 16, 22, and 28. So we can see here that we've got an upward slope taking place. So if we have to describe this graph, we can say that we've got a linear graph because we've got a straight line with an upwards slope because we can see that it's sloping up from left to right, which indicates linear growth. So remember, growth is that keyword we want to use here because we can see that the perimeter is increasing each time. Now, the final question here, it says use the rule for the nth term to predict the perimeter of the 50th snake. So this wants us to rewrite it now to find it for any term. So remember the nth term, so we need to say Pn equals A, so our first value, which was 10, plus n minus 1 times the common difference, which in this case is plus 6. And it wants us to find the 50th snake here. So I've got 10 plus 50 minus 1 times 6. And if we go to our calculator, we can type that in exactly how it's written. And we will find that the 50th snake has a perimeter then of 304 units. So we can see here that this rule for the nth term is quite handy. I'm not having to enter that in my calculator and press enter 50 times, which would be really time consuming. I can just substitute in 50 and find out that the 50th snake has a perimeter of 304 units. So now you have the skills to work on 8D. You can see that we have two types of rule that we're using, a recurrence relation, which is when we explicitly state this T1 value first and then write the next term in terms of the previous term, and we have this rule for the nth term. So you will be asked to write rules in either format and need to be able to switch between both formats as well throughout this exercise.